Okay, guys. So in today's class, we are going to be covering the topic of symmetry. And we are going to be looking at symmetry of two-dimensional objects and three-dimensional objects. When we are considering two-dimensional objects, the symmetry of two-dimensional object is going to be divided into two parts: reflection symmetry and rotational symmetry. Okay. And for 3D figures, it's going to be divided into two parts: plane symmetry and rotational symmetry. So if I show you this figure, how many lines of symmetry are going to be there? A line of symmetry is a line that is going to divide the shape into two identical halves. So you can observe over here that this shape can have this line of symmetry so that the both halves can be exactly overlap each other, or it can have this as a line of symmetry so that the top part and the bottom part can overlap each other. So this shape has two lines of symmetry. Two lines of symmetry. Okay, it's a 2D shape. Consider another example. This is a star. Okay, and you can see that it has four lines of symmetry. So four lines of symmetry for this object. Okay. Now, this was the line of symmetry. Okay, also called the reflection symmetry. Now let's discuss the rotational symmetry. Rotational symmetry means that this figure needs to be rotated how many times in 360-degree so that you get the same shape. So there is something called the order of rotational symmetry. Order of rotational symmetry. Okay, so if I am going to rotate this shape 90-degree clockwise, this is the result. Is this figure the same as this? Is this orientation the same as the previous one? No. Okay. Now you're going to rotate this figure 90-degree again. So this shape and this shape has the same orientation. Okay. So that your counter is going to increase by 1. Previously, the rotational symmetry was 0. Now, after 180-degree, you're going to get the same shape. And then after 180-degree again, you're going to get the same shape. So in 360-degree, you are getting the same shape two times. So this figure has a rotational symmetry of order 2. So this shape has a rotational symmetry of order 2, as it will fit back in its outline 2 times in a full turn. Okay. For example, if I rotate this shape 90-degree, okay, it doesn't fit its outline, right? It doesn't fit its outline. But when I rotate it 180-degree, it does fit the outline. So that is one full turn when you are getting, you can say that is one rotation when you get exactly the same shape. And this is going to happen again when you rotate it 180-degree again. So in 360-degree, how many times do you need to turn this shape? You need to turn this shape 2 times, or the shape can be turned 2 times in 360-degree so that the shape looks identical. So then you are going to say that the order of rotational symmetry for this shape is 2. Okay. What do you think about this shape, the star? How many order of rotation? What's the order of rotational symmetry of this shape?
4.
Okay, that's correct. This has a order of rotational symmetry of 4 because after turning 90°, let's consider this point. After turning 90°, this point is going to come over here. And after 90°, the shape exactly looks alike. After turning again 90°, you are going to get the same shape. After turning further 90°, you are going to get the same shape. And after turning 90° further, you are going to get the same shape. So in 360°, there it needs to take 4 turns, okay, to fit the outline. So this shape has a rotational symmetry of order 2. Okay. So let's consider few further example. So we are clear with this point that a line of symmetry divides two-dimensional shape into two congruent or identical shapes. Okay. A two-dimensional shape has a rotational symmetry if when rotated about a central point, it fits its outline. The number of times it fits its outline during a complete revolution is called the order of rotational symmetry. Okay. Consider this triangle. It's a scalene triangle. Scalene triangle is a triangle that doesn't have any equal angle. Okay, none of the angles are equal. So how many lines of symmetry does this scalene triangle have? 0. You don't have any line of symmetry. You pass a line like this, it's not
Sir,
symmetrical, not symmetrical, not symmetrical. Yeah. Any questions?
no.
Okay, what can we say about the order of rotational symmetry of this figure? In 360°, how many times will it fit its outline? If this shape is rotated 360°, okay, how many times will it match its outline? So after rotating, let's say 90°, doesn't fit the outline, 180° doesn't fit the outline, 270° doesn't fit the outline, 360°, yes, it fits the outline again. So in 360°, it only fits the outline once. Hence, the order of rotational symmetry is 1. Make sense? Everyone is clear?
Yes.
Okay, now isosceles triangle. An isosceles triangle has the two adjacent sides equal. So if you pass a vertical line like this, it's going to divide the entire triangle into two congruent triangles. So there is one line of symmetry. Okay. Only one line of symmetry. And to figure out the order of rotational symmetry, you're going to check how many times will it fit its outline when rotated 360° about the x-axis, 360° about the point, about the central point. So if you rotated 90°, 180°, 270°, 360°, it only fits the outline once in 360°. So the order of rotational symmetry is 1. Equilateral triangle. Equilateral triangle is a triangle in which each angle is equal and equal to 60°. If you pass a vertical line like this, it's going to divide your equilateral triangle into two parts. If you pass a vertical line from this vertex, it's going to divide the equilateral triangle into two parts, and the same goes for this line. So it has 3 lines of symmetry. Okay, and it's a regular polygon. Any regular polygon, remember what the regular polygon was? A polygon means more than 2 sides figure. Okay, a regular polygon would mean that all the interior angles are equal and all the sides of a polygon are equal. So equilateral triangle is a regular polygon. the number of lines of symmetry of a regular polygon is going to be equal to the number of sides. So if equilateral triangle has 3 equal sides, then the number of lines of symmetry is going to be 3. And to figure out the rotational symmetry, okay, if you rotate this 3, you are going to check how many times do I need to rotate it in 360 so that it gives you the same shape. So you are going to notice that it rotates once. Sorry, it rotates once like this, once, twice, and then 3 times. Okay, I'll mark a point over here so that it's clear to you. This is the point, okay? So in 360 degree, how many times it fits its outline? Once, twice, okay, and then thrice. So order of rotational symmetry is going to be 3. If the order of rotational symmetry is 3, that means that in 3 times it is going to map on its original outline. So what is the angle of rotation over here? The angle of rotation is going to be 360 divided by the order of rotational symmetry, that is 3. So that is 120 degree. So after every 120 degree, if you're going to rotate this point 120 degree, this point is going to come over here. Okay, if this point is rotated further 120 degree, it's going to come over here. And if it is rotated 120 degree again, it's going to come back to its original position. Yeah, clear?
Yes.
Okay. Now let's deal with quadrilaterals. The first one is a rectangle. A rectangle has 2 lines of symmetry, one vertical, one horizontal. So the number of lines of symmetry is 2, and the order of rotational symmetry is also 2. After 180 degree, you are going to be getting the same rectangle. So in 360 degree, it needs to be turned twice. Okay, so 180 degree, you get a rectangle again, and rotating at 360 degree, you get the same rectangle. Okay, so in 360 degree, the order of rotational symmetry for rectangle is going to be 2. Now square is a regular polygon. So since there are 4 sides, there are going to be 4 lines of symmetry, vertical, horizontal, and 2 diagonals. Okay, and the order of rotational symmetry is also going to be 4. Because if you rotate the square 90 degree, you're going to get this shape. So it does maps the outline. 180 degree, again you get the same shape. 270 degree, you get the same shape, and 360 degree, you get the same shape again. So there are 4 order of rotational symmetry. Square has 4 order of rotational symmetry of 4. Then the next shape is a parallelogram. Parallelogram doesn't have any line of symmetry. Okay, neither vertical nor horizontal, neither diagonal. But it has the order of rotational symmetry of 2, because after 180 degree, you are going to get exactly the same shape. After rotating it 180 degree, you're going to be getting the same shape. That is 180 degree. And after 360 degree, you get you again get the same shape. So in 360 degree, how many times does it fit its outline? 2. That's why the order of rotational symmetry of a parallelogram is 2. Now the rhombus has all sides equal. But is rhombus a regular polygon? No, because all the angles in a rhombus are not equal. So that's why it doesn't have an 4 lines of symmetry. It has, you can see it has only diagonal lines as acting as line of symmetry. So there are only 2 lines of symmetry. And again, this shape has an order of rotational symmetry of 2. Then you come to isosceles trapezium. Isosceles trapezium is a trapezium in which these 2 sides are going to be equal in length and these 2 sides are parallel. Okay, these 2 angles are equal, these 2 angles are equal. Now, how many lines of symmetry does this isosceles trapezium has? Just 1. Okay, only vertical line of symmetry. And this figure has an order of rotational symmetry of 1, which means that in 360-degree, it can only fits its outline once. Then the next shape is a kite. A kite has these 2 sides equal and these 2 sides equal in length. Only the longer diagonal acts as a line of symmetry. Okay, only this is the line of symmetry. There is no horizontal line of symmetry, as this point can and this point cannot overlap each other. So there is only one line of symmetry, and there's only one. The order of rotation symmetry of the kite is also 1. Do we have any questions still here? Please ask right now.
No, sir.
Okay. Find the order of rotational symmetry of these shapes. The first one is a triangle. What is it? A specific triangle?
Equilateral.
Equilateral triangle? Yes. So what's the order of rotational symmetry of this shape?
3.
It's 3. Okay. What is this? Which shape is this?
Hexagon.
Hexagon. How many lines of symmetry does an hexagon have?
4.
Hexagon will have, okay, hexagon will have 6 lines of symmetry, but right now we need to find the order of rotational symmetry. So what's going to be the order of rotational symmetry?
4.
Order of rotational symmetry is going to be 6. Okay. Please remember that a regular polygon with n sides will have n lines of symmetry and an order of rotational symmetry of n. So it's a regular hexagon, so it will have the order of rotational symmetry of 6. Okay. Then you have this scalene triangle. So you can say it does not have any rotational symmetry. Okay. So, or alternately, you can say that it has an order of rotational symmetry, order of rotational symmetry. Yeah, or you can say rotational symmetry of order 1. Order 1 means that it doesn't have any rotational symmetry. It is just going to be back on its outline after 360-degree. Are we clear till here?
Sir, isn't this isosceles?
Well, the dimensions are not given. I consider it to be a scalene, but yes, if this would have been an isosceles, then the working would have been. Oh, by the way, even if it is isosceles or scalene, it will have an order of rotational symmetry of 1. Okay, we are talking about the rotational symmetry. However, if okay, let's consider this to be an isosceles triangle. I think you're right, but the line of symmetry is going to be 1. Scaling triangle has a line of symmetry, has 0 lines of symmetry. Isosceles triangle has 1 line of symmetry. But this question was about rotational symmetry. So does this figure has a rotational symmetry? No. Not having a rotational symmetry means rotational symmetry of order 1. Okay, Zarva?
Yeah.
Okay. Okay, now we are going to study 3D shapes, symmetry in 3D shapes. There are two types of symmetry in 3-dimensional shapes. The first one is the plane of symmetry, plane symmetry, and the second is called the rotational symmetry. So first we are going to consider the plane symmetry. A plane of symmetry, a plane basically is a flat surface, okay? So if you cut a 3D shape in half, so each half is the mirror image of the other half. Then the object or the solid has plane symmetry. Okay, for example, if I have this cuboid and if I half it from here, from the center, the top part is going to be separated and the bottom part is going to be separated. So yes, this shape has a plane symmetry. Okay, a plane of symmetry divides a solid into two identical parts. The cuboid has 3 planes of symmetry. So you can pass a plane over here at the from this face, and this part is going to be separated. So the one of the plane of symmetry is this. The second one is this, so that the top part and the bottom part is separated. And the third plane of symmetry is from this face, you pass a plane like this, so that the front and the back is separated. Can everyone visualize the planes of symmetry of a cuboid? Yes or no? Zarva, Omar, can you guys visualize the planes of symmetry of a cuboid?
Yes.
Okay,
So it can also be divided diagonally.
sorry.
It can also be
No,
divided
for
diagonally.
cuboid, we don't have a diagonal line, diagonal plane of symmetry. Okay, for cuboid, we don't have it. Okay, now let's discuss rotational symmetry. Okay, imagine, okay, this is the cuboid. Imagine I pass a rod, I made some holes on this top and the bottom, and I pass a rod. Okay, the rod forms an axis for the shape to turn around. If you rotate the shape around the axis, okay, if you're going to keep on rotating it, it looks the same at different points of rotation. Okay, so if I keep on rotating this, it is going to be looking exactly the same. So it has a rotational symmetry. And the rod, this rod is going to be considered the axis of symmetry. So one of the axes of symmetry is this. If I'm considering this as my axis of symmetry, then the entire cuboid can rotate around like this. If I consider from this face, if I pass a rod, I can rotate the cuboid like in this direction. Okay, or if I pass a axis from this face, then I can rotate the cuboid in this direction, in this way. Okay, so how many axes do you see? There are 3 axes of symmetry. Okay, now for any axis of symmetry, what is going to be the order of rotational symmetry? When you are going to visualize this shape in 3D, okay, it's a 3D shape. When you are going to turn this shape, okay, when you're going to turn this shape 180 degree, this point is going to go after 180 degree, this point is going to go over here. Okay. If this is point A, so that is going to be A dash. That is your point A. Let's consider it as A. And after 180 degree, again, this point A is going to come back to this point again. So in 360 degree, you have to rotate it 2 times so that it gives you the same shape. Okay. So we are going to say that a cuboid has a rotational symmetry of order 2 about the axis given. Even for this axis, it has an order of rotational symmetry 2. Even at this axis, it has a rotational symmetry of order 2. So a cuboid has 3 axes of rotational symmetry. We have discussed this. These are the 3 axes. When you are asked to describe the symmetry of a shape, remember to describe both the rotational and the line symmetry. In case of 3D shape, you're going to describe the rotational and plane symmetry. So how would you describe the symmetry of a cuboid? You are going to say that the cuboid has three planes of symmetry and a rotational symmetry of order 2. Please ask if you guys have any questions till here.
So in a cuboid, all sides are same, right?
In a cuboid, not all the sides are not the same. If all the sides would have been the same, it would have been called a cube. Okay, that was the cuboid. Now, this is the cube, and you are going to notice that the cube has 9 planes of symmetry. Okay, first one is this horizontal, then this one. Over here, the top and the bottom are going to be separated. Over here, the front and the back are going to be separated. When this is the plane, the front and the back are going to be separated. A cube can have this diagonal plane as well. So this right angle triangle, this prism and this prism are separated. It can also have like this, so that this part and this part is separated. Even this, so this part, this prism and this prism is separated. So the idea is to show you guys that it has 9 planes of symmetry. Okay. This figure has 9 planes of symmetry. So please remember that a cube has 9 planes of symmetries. Okay, now my question to you is, consider this cube and consider this axis. What is the order of rotational symmetry of the cube about this axis? What is the rotational symmetry order for the cube?
4.
4. Very good. So you always see the base. If the base has 4 lines of symmetry, then the rotational symmetry of the cube of the solid 3D figure is also going to be 4. Okay, let's try this one. Write down the order of the symmetry of the triangular prism. So about this axis, what is the order of symmetry? So
Is it
consider this
3?
to be a equilateral triangle. Okay. So after 120 degree, this point, if you rotate it like this, after 120 degree, this point is going to come over here. Then after 120 degree, this point is going to come over here. Then after 180 degree, this point is going to come again. So in 360 degree, there are 3 times that it's going to be having the same shape. So it has a rotational symmetry of order 3 around the given axis. Zarwa, is this example clear?
Yes.
Okay, how many planes of symmetry does the cylinder has? Planes of symmetry, guys. What do you say? How many will it be?
2.
Think again.
Unlimited.
Infinite. Very good. So there are going to be infinite planes of symmetry. Okay. Why? Because the base is a circle, and the circle has infinite lines of symmetry. So there are going to be infinite planes of symmetry. A plane is going to look like this. Okay, and there are going to be infinite of these. Okay, true or false? An isosceles triangular base prism has 2 planes of symmetry. Well, I've done this for you. Read the question and ask if you have any questions.
It only has one, sir. Is it false?
Zarwa, what do you say? It's true.
Two.
An isosceles triangular base prism has 2 planes of symmetry because either if it's an isosceles triangle, there's this line symmetry. You can pass a plane like this. It's going to divide the 2 prisms equally, or you can pass a plane like this at the center. Okay, so when you're going to pass a plane like this part and this part is going to be separated, so it has 2 planes of symmetry.
So line of symmetry is used in 2D shapes, right? And plane of
And
symmetry is used in
symmetry
3D
used in
shape.
2D. Yes. Okay. Sophie thinks that that a rectangular base pyramid and a square base pyramid have equal number of planes of symmetry. Is she correct? Answer with yes or no. So I have drawn both the figures for you. This is a rectangular base pyramid and this is a square base pyramid. The rectangular base pyramid has a base rectangle. So it has only 2 lines of symmetry, vertical and horizontal, and hence it has 2 planes of symmetry only. Okay. So it has 2 planes of symmetry. When you have a square base pyramid, the base is a square. A square has 4 lines of symmetry, 2 diagonals, 1 vertical and 1 horizontal. Okay. So there are going to be 4 planes of symmetry as well. There's going to be a plane over here. There could be a plane over here. There could be a plane like this. Okay, so there are going to be 4 planes of symmetry. So is she correct? No. She says that they both will have same planes of symmetry. She is not correct. Okay. Okay. An isosceles triangular base prism has 2 planes of symmetry. Give your answer.
Yes, that's 2. We just did it.
An isosceles triangular base prism has 2 planes of symmetry. Okay, that's true. And that's hold on. An isosceles triangular base prism. Yes, it's true. Okay. Try the next.
So,
We have done these. Okay. Now
yes.
Determine the order of rotational symmetry of this square base pyramid for a rotation about the given axis. Come on, guys, tell me the answer.
4.
Determine the order of rotational symmetry of this square base pyramid. Yes, the square, because the base is a square, it has order of rotational symmetry of 4. So hence it is going, the order of rotational symmetry of the square base pyramid is also going to be 4. Okay, what is the order of rotational symmetry of this regular hexagonal prism about the given axis?
6.
It is very good. It is 6. It's a regular hexagonal prism. So the answer is going to be 6. These solids have the same order of rotational symmetry, right? True or false?
2.
Yes, they have the same order of rotational symmetry. The order of rotational symmetry over here is also infinite. And over here is also infinite because the bases are circles. Okay, and circle has infinite lines of symmetry. The diagram shows 3 possible axes of symmetry through a cuboid. Will there be a different order of rotational symmetry for each one? If you consider this as your axis of symmetry, then the order of rotational symmetry is
2.
2. If you consider this as your axis of rotational symmetry, the order of rotational symmetry is
2.
think again.
4.
That's also a rectangle. The order of rotational symmetry is going to be 2. This one is also a rectangle. The order of rotational symmetry is going to be 2. Okay. So the answer is no. They don't have a different rotational symmetry. They all have the same rotational symmetry.
Sir, are these past paper questions?
No, these are not past paper questions. These are some conceptual questions. Now we are going to be doing past paper questions. Okay. Tell me the answer for the first part. A quadrilateral that has one line of symmetry and no rotational symmetry. One line of symmetry and no rotational symmetry. No rotational symmetry means order of rotational symmetry is 1. Okay. So it can either be a parallelogram or a kite. A quadrilateral has rotational symmetry of order 2 and no lines of symmetry. Which quadrilateral has a order of rotational symmetry of order 2 and no line of symmetry? Sorry, for the first one, it has one line of symmetry. Parallelogram doesn't have any line of symmetry. It can either be a kite, okay, because a kite has a one line of symmetry, or it can be a isosceles trapezium. Please correct it. So if you have an isosceles trapezium, it is going to have one line of symmetry, and the order of rotational symmetry is going to be 1, which means no rotational symmetry. Hence, it can be a kite or isosceles trapezium. Okay, question number 2. A quadrilateral has rotational symmetry of order 2 and no line of symmetry. So the quadrilateral that doesn't have any line of symmetry is the parallelogram. Okay. Okay. Question number
So
3.
sir,
Yeah.
it has two line of symmetry.
It doesn't have any line of symmetry. If you're going to say that it has a horizontal line of symmetry, this point and this point are not going to overlap each other. If you pass a vertical line, this point and this point are not going to coincide. So it doesn't have any line of symmetry, but it has a rotational symmetry of order 2. Okay. After 180 degree, it's going to be on the same outline. And after 360 degree, it's going to be on the same outline. So it has a rotational symmetry of order 2. Question number 3, zebra. These are the letters. Write down the letters in the word above that have exactly one line of symmetry. So out of these letters, which has only exactly one line of symmetry?
A.
A. It can be E as well, and it can be B as well. Okay. If you pass a line like this, it has the line exactly one line of symmetry. Okay. Now, write down the letters that have a rotational symmetry of order 2.
Z.
Z. Correct. Okay. The word is trigonometry. Write down the letters which have exactly two lines of symmetry.
I, O,
O doesn't have any.
T.
O doesn't have any finite line of symmetry. It has infinite line of symmetry.
T.
Okay. I. Yes, for the first part, only I is going to be the answer. I has two lines of symmetry. Okay, rotational symmetry of order 2. How many letters have rotational symmetry of order 2?
O.
O has infinite
Sorry.
lines.
Yes.
Okay, it's going to be I again, because if you rotate I 180 degree, it's going to be the same I, and after 360 degree, it's going to be the same I, and the next one is going to be N. If you rotate N, it's going to be N 180 degree, 360 degree. So it has an order of rotational symmetry of 2. Okay, write down the order of rotational symmetry of this shape. So this shape is, can you guys guess the order of rotational symmetry? The triangles are identical over here. One turn, 2, 3, 4, 5, 6, 7, 8. So what's the order of rotational symmetry for this figure? Would you guys agree that it's 8? 8 times it can fit its outline. Getting the idea? Is this example clear to everyone? Yes or no? Zarva, Omar?
yes.
Yes.
Okay, let's do question number 9 now. The diagram shows a regular pentagon and kite. Complete the following statement. The regular pentagon has dashed lines of symmetry. If it's a regular pentagon, how many lines of symmetry will it have?
1.
5. Regular pentagon will have the same number of lines of symmetry as the number of sides, so there are 5. The kite has a rotational symmetry of order. What's the answer for this?
1,
1. Good.
So how are there 5 lines of symmetry in a pentagon?
It's a regular pentagon, Omar. So it will have 5 lines of symmetry.
Yes, yes. Okay.
Okay. Write down which one of these shape has rotational symmetry of order 2 and no line symmetry.
Parallelogram.
Yes, parallelogram. Okay, question number 11. The diagram shows a cuboid. How many planes of symmetry does this cuboid has?
2.
3. Remember, there were 3 planes of symmetry. One was like this. One was like this. Okay. And the next one is going to be like this. It has 3 planes of symmetry. Write down the order of rotational symmetry for the following diagram. What is the order of rotational symmetry for this diagram? Try to understand the diagram. How many turns will it need in 360-degree?
It's
4.
going to be infinite.
4,
Yeah,
right? So each
4.
angle after rotating 90-degree, you're going to be getting the same shape. So in 360-degree, the order of rotational symmetry is going to be 4. Okay, the diagram shows a cuboid which has no square faces. Draw one of the planes of symmetry of the cuboid on the diagram. So you just need to draw one of the plane of symmetry. So you can just draw one plane. Okay. The diagram shows a pyramid with a square base. The triangular faces are congruent isosceles triangles. Write down the number of planes of symmetry for this pyramid. The number of planes of symmetry for it has a square base. So how many planes of symmetry will it have?
4.
Yeah, it square has 4 lines of symmetry, so it will have 4 planes of symmetry. The pyramid below has a rectangular base. The vertex of the pyramid is vertically above the center of the base. Write down the number of planes of symmetry of the pyramid. How many planes of symmetry will this pyramid has? How many lines of symmetry does a base rectangle has? 2. So there are going to be 2 planes of symmetry. Okay, the cuboid has a square cross section. So this is your square. Write down the number of the planes of symmetry.
4.
Planes of symmetry. See, one is going to be this plane. One is going to be the horizontal plane. Okay. One vertical, one horizontal. One plane is going to be like this. These are the normal 3 planes. But because it's a square, okay, that's the third plane. But because it's a square, it will also have diagonal plane like this. Okay. And also this diagonal. So 2 of these and 3 of these. So in total, there are 5 planes of symmetry. Okay. Just try part B and 16. I'll just wait for the azan. The cuboid has a rectangular cross section. The axis shown passes through the center of the 2 opposite faces. Write down the order of the rotational symmetry of the cuboid about this axis. So about this axis, it has 2 order of rotational symmetry of 2. Then question number 16 says add one line on the diagram so that it has 2 lines of symmetry. Okay. So you just need to add one more line so that the shape has 2 lines of symmetry. So all you need to do is complete the rectangle. The rectangle will have two lines of symmetry. Now in the next part, it says add two lines on the diagram so that it has a rotational symmetry of order 2. So the two lines are going to be this and this. Okay. Would you agree that this shape will have a rotational symmetry of order 2? Yeah. There were other possibilities as well. You could have added one of this line and then divided it into two parts. So these are the two lines. Again, it has a rotational symmetry of order 2. Or you would have passed a line like this, or the other way. Or you could have passed the second line like this. All will have a rotational symmetry of order 2. Okay, now these are the shading questions. Okay, question number 17A says, write down the number of lines of symmetry for the diagram below. How many lines of symmetry will the following diagram have?
0.
0. Very good. Because if you pass a line like this, the squares don't overlap. If you pass a line like this, these squares don't overlap. Okay, the black ones have to overlap the black ones, so there is no line of symmetry. Okay, write down the order of rotational symmetry for the diagram below. This will have an order of rotational symmetry of
2.
2. Okay, good. Let's try the last one. Shade one square in each diagram so that there is one line of symmetry. So there are 3 boxes shaded. You need to shade one more box so that there is one line of symmetry. Where should I shade this?
Top right.
Top right. Very good. So this is the shaded box. And if you pass a line like this box is going to overlap this one, and this box is going to overlap this one. Good. Shade one box, shade one square, so that this diagram has a rotational symmetry of order 2.
Bottom right.
Bottom right. Correct. Okay, so this shape will have a order of rotational symmetry of 2. Okay. Then okay, now the last question 19. The diagram shows a regular pentagon. It's a regular pentagon, meaning all the angles are equal. AB is the line of symmetry. Work out the value of D. Guys, if it's a pentagon, then each angle of a pentagon is equal to, it's calculated as n minus 2 times 180 divided by n. So it's a pentagon, so 5 minus 2 times 180 divided by 5. Zarva, please calculate this for me. What is each interior angle of a pentagon equal to?
108.
Yeah, 108. So this entire angle is 108. And if AB is a line of symmetry, would you agree that these two angles are going to be divided into half? So D value is going to be
54.
54. Okay, so that's all about symmetry. It was a small topic and we have covered it.